Hello, my name is Bettina McDowell and I work for IWMA, the International Water Mist Association. Just a few words about the organization. IWMA was established in 1998 and has been and still is the only organization worldwide solely dedicated to the water mist technology. We have over 60 corporate and private members from all over the world and are a forum for manufacturers, distributors, installers, insurance companies, research institutes, architects, building engineers, fire consultants, and so on. Today I'm going to explain how water mist works. I'm going to say something about the benefits of water mist, about standards and guidelines, and I will list some applications. You most probably know that a fire triangle comprises 3 elements: the fuel, the heat, and the oxygen. The thing is that water mist reduces 2 of these elements, that is, the heat and the oxygen. And water mist is a performance-based technology, which means that you will always get a bespoke system for your application, which is based on a real scale fire test, not on computer simulation, because water mist is not a one-fits-all concept. When it comes to the definition of the different water mist systems, you can see that low-pressure systems work with a pressure below 12.5 bar. High-pressure systems work with a pressure above 35 bar. Systems ranging between these 2 figures are defined as intermediate pressure systems. Now, this is according to the 2 North American standards FM 5560 and NFPA 750. There is the VDS guideline 3188, and in there it says that there are merely 2 systems: low pressure systems that remain below 16 bar or 232 psi, and high pressure systems that exceed 16 bar. Here you can see that NFPA, the National Fire Protection Association, and then the European Committee for Standardization have a slightly different opinion when it comes to the number of droplets that should be less than 1 millimeter or 1,000 microns in size. However, what is more important than the question whether 90% or 99% of the droplets are less than 1 millimeter in size is the fact that water mist is defined by droplet size, and that the droplets that a water mist system produces interact with the fire so as to reduce the heat as well as the oxygen. The droplet size is a result of the pressure of the system, but also of the type of nozzle, and the smaller the droplets, the quicker they obviously evaporate. So how does they all fit together? What happens if a fire breaks out and the water mist system is activated? Water mist attacks the fire by spraying water through nozzles especially designed for this purpose. And the smaller the droplets, the larger the overall surface. You can see that here on the right-hand side. After a system has been activated, the released droplets evaporate and turn into steam. And it is this steam, fog, or mist, or whatever you want to call it, that interacts with the fire. Due to the enormous increase in the volume of the water droplets as they evaporate, the oxygen is displaced at the source of the fire and the flames are extinguished. During this extinguishing process, the oxygen content around the fire and only there drops to below 12%. And it is this low oxygen content that suffocates the fire. This is called the local inerting effect. Further away from the fire, the oxygen content is well above 12%, which means that there is enough oxygen available for humans. What I would like to add is that when water evaporates, it expands approximately 1,700 times. So 1 liter of water turns into 1.7 cubic meters of vapor. And with small droplets, there is an increased surface area that will absorb heat and increase the potential for evaporation. I would also like to add that the additional cooling effect prevents reignition. However, The droplets need a fire of a certain size. Fact is that water mist systems may have a bit of an issue with small fires because these fires just don't have the force to evaporate the droplets. But still, the system will keep the fire in check until the fire brigade arrives. When it comes to the benefits of water mist, I would like to highlight the diversity. I have mentioned that water mist systems produce very small droplets. As a result, we have a suppressant agent that is applicable on a broad range of fire types. The reason for this is that the droplets turn into steam. In the chart, you can see that water mist ticks nearly all the boxes. In fact, no other kind of fire suppression system ticks more boxes than water mist. I would like to explain something regarding electric and cooking oil fires, the two columns on the right-hand side. With water mist, we are not looking for the effect of the water extinguishing the fire, but the mist. So we want to provide a setting in which the droplets can turn into mist, and you can do this by making sure that the mist hovers above the flames and then sinks down to get the results you would obviously want to achieve. And the nozzle must, of course, not point into the flames. Next, I would like to stress the eco-friendliness of water mist systems. What makes water mist systems eco-friendly? First of all, a water mist system obviously uses water, and what is more natural than water? When a water mist system uses a relatively small amount of water, in fact up to 85% less than a traditional sprinkler system, then you have less material due to, for example, smaller pipes, smaller tanks, and so on. We recommend the use of stainless steel for components that come into contact with water to avoid corrosion and thus contamination, and to support the longevity of the systems, which in itself is a sustainable and eco-friendly approach. The other thing about stainless steel is that it can be reused and thus be reintegrated into the life cycle. And then I would like to point out the reduced water damage, which means that after a fire there is less debris that has to be disposed of. Plus, in consequence, there might well be, for example, less downtime for businesses. Another challenge is the disposal of the residue after fire incidents in hazardous areas like, for example, the nuclear industry and in pharmaceutical and electronic manufacturing. When a fire breaks out in such areas, this can result in the release of many different toxins and chemicals from the fuel of the fire and or the gases. The fire water gathers these substances and has to be picked up and disposed of after the fire, which is a difficult job that becomes easier the less water there is. Another slide about the benefits of water mist, and this is basically a summary of what I've already said before, plus there are some additional points. So with a water mist system, you need a relatively small amount of water, a relatively small amount of space, and also the components are quite small, which means that you can save material. I have explained that water mist systems reduce the heat and the oxygen. What I would like to add here is that water mist also wets the surroundings, thus affecting also the third side of the triangle, although not as much as traditional sprinklers. Water mist does not harm humans. I've described the local inerting effect. Water mist systems are easy and fast to install. Water mist systems are also easy to retrofit. And a water mist system can easily be extended. Some systems can be connected to the normal domestic water supply. The cooling effect prevents reignition. Another point is the room filling effect. Due to the size of the droplets, water mist is well distributed, fills many nooks and crevices within seconds of activation. Water mist can be carried around with the airflow and is therefore not depending on hitting the fire directly. It is therefore able to control or extinguish even concealed fires. When it comes to smoke control, water mist will efficiently cool the smoke layer, preventing the hot gas layer to contribute to further fire spread. The water mist will also clean out some of the smoke particles. And the technology is proven to international standards and guidelines and is therefore ready to use. Standards and guidelines. There are the IMO standards. IMO, the International Maritime Organization, was one of the first organizations to publish a water mist standard. In 1995, FM 5560 was published, followed by NFPA 750 just 1 year later. UL 2167 was first published in 2002, and the VDS guideline was first published in 2015. Then there are national and regional standards. All standards are updated, revised and updated on a regular basis. The list that you see here is not exhaustive, but most of the current standards are listed here. For us, the most important standard is the EN 14972. EN 14972-1 was published in December 2020. That's the part entitled Design, Installation, Inspection and Maintenance. And in there, the concept that water mist systems are performance-based is defined and described. The European standard reflects the uniqueness of each system. It is rather the template for how a manual should be written and what it must contain. And there is indeed a DIOM manual for every system, which has to stick to the specifications provided by the standard. The letters DIOM stand for Design, Installation, Operation and Maintenance, and manufacturers provide this manual specific to their system. The EN 14972 series consists of 17 parts. Some of these parts, including part 1, have been published. Others are to follow suit in the near future. And something about maintenance. Uniform maintenance routines are applied throughout the water mist industry. Maintenance requirements for water mist systems are comparable to conventional sprinkler or gas extinguishing systems. And I would like to mention the metrics. The metrics can be found on the IWMA webpage. The metrics is an IWMA project, and it's a chart of all current water mist applications and associated fire test protocols that have been published by certification and test agencies. Here you can see that water mist systems are installed and used basically all over the world. Famous buildings or spaces that are protected with water mist are St. Patrick's Church in the center of Manhattan. Then there is the famous Opera House La Scala in Milan, Italy. The clock tower in Mecca is protected with water mist, so is the Eurotunnel, that's the underground tunnel that connects Great Britain to the continent. And there is even a water mist in space. The ISS, the International Space Station, carries portable water mist extinguishers. Then there is also St. Mark's Basilica in Venice. Then there is the archive at the Bodleian Library at Oxford University. There is a concert hall in Hamburg, which is still quite new, the Elbphilharmonie, that's protected with water mist. And also Windsor Castle is protected with water mist. Now come a number of slides showing segments, key verticals, and applications. I will not go into detail. What I would like to mention is that also these lists are not exhaustive. Here you see lens segment, key verticals relating to the building segment. And on the next slide, the same thing relating to the industrial segment. And then there is also the marine sector. What I would like to mention here is that water mist was actually first relaunched in the 1980s as an alternative to firefighting systems in marine applications. And this would bring us to where it all started, to the history of water mist. You can see this in another video that will be published soon here on the IWMA YouTube channel and on the IWMA webpage. So thank you very much for your attention. These are my contact details. If you would like to get in touch with IWMA, you're very welcome to do so. I'm looking forward to it. Bye-bye. Thank you.